So back in 2025, our solar system got a visitor. And I mean a visitor from way out there, hurtling in from interstellar space. It was designated 3I/Atlas, only the third one of these things we'd ever seen. But let me tell you, this was no ordinary comet. And the story of what it really was, well, it's a whole lot stranger than you might think.
Right from the get-go, its behavior was just bizarre. It completely split the scientific community. Were we looking at some kind of natural wonder from another star system, or was it something else, something not made by nature at all?
Okay, so let's get our bearings with a quick timeline of its wild ride. It's spotted in July, then it ducks behind the sun right when things are getting crazy in October. Miraculously, it pops back out in November and then makes its closest flyby of Earth in December, a real whirlwind tour.
Let's start with the first clues. Because even when it was still far away, astronomers knew they were looking at something special, something that just didn't play by the usual rules for comets.
The weirdness started piling up almost immediately. For one, it was just gushing water, like a fire hose, out in the freezing cold depths of space where that shouldn't happen. Then it started changing colors, going from red to green and then looking blue to our solar probes. And get this, it had a jet of material pointing towards the sun, which is totally backward. To top it all off, its gassy atmosphere was full of nickel vapor, something you just don't see until a comet gets way, way hotter.
But the real jaw-dropper was its chemistry. The ratio of carbon dioxide to water was 7.6. Now, to give you some perspective, a typical comet in our solar system has a ratio of like 0.12. This thing wasn't just a dirty snowball, it was basically a giant block of dry ice with almost 60 times more CO2 than we've ever seen.
And just as everyone was scratching their heads, 3I/Atlas slipped behind the sun. From down here on Earth, the show was over. But luckily for us, our robotic fleet out in space had front row seats.
You know, that's the amazing part. We had a whole network of eyes on it. So there are observatories like SOHO and Stereo A, even our orbiters around Mars. They all turned to watch. They gave us this continuous, uninterrupted view of the comet's transformation as it took the full blast of the sun's heat.
And what they saw was absolutely stunning. This thing went through a total metamorphosis. Its brightness didn't just ramp up, it exploded. The object was blowing off so much material and flaring so intensely that the chart of its brightness basically went straight up, almost vertical. It completely defied all the standard models.
And while all that was happening, millions of miles away on the surface of Mars, the Perseverance rover just looked up, and it snapped this picture. Now I know, it looks like a faint little smudge, but this image is historic. It's the first time in human history we've ever taken a picture of an object from another star system from the surface of another planet. Just think about that for a second.
So, with all this truly bizarre behavior, the question that was on everyone's mind became impossible to ignore. Were we really looking at a comet, or was this something else? The debate was on: natural phenomenon versus alien technology.
And the debate really came down to two totally different ways of seeing the evidence. Proponents of the alien theory said, look, that sunward jet, that's a thruster, and its path is way too stable. It must be under controlled propulsion. But the scientific evidence painted a different picture. Cometary scientists pointed out that actually, sunward jets are a known thing, and its acceleration matched up perfectly with the ridiculous amount of gas it was spewing.
And that claim about its stable trajectory? Well, let's look at the data. This chart shows what's called non-gravitational acceleration, which is basically how much a comet gets pushed around by things other than gravity, like its own jets. 3I/Atlas was wobbling by about 1.5 kilometers a day. Compare that to the famous comet Hale-Bopp at 10, or the other interstellar visitor 2I/Borisov at a whopping 100. All of a sudden, 3I/Atlas doesn't look artificially stable at all. In fact, it was remarkably steady.
But the final nail in the coffin for the spaceship theory came from the ground. In South Africa, the incredible Meerkat radio telescope array managed to peer right through all the dust and gas, and it picked up a clear, undeniable radio signal of hydroxyl radicals, which is what water breaks down into. We're talking tons and tons of water.
That radio signal was the smoking gun. It proved beyond a doubt that 3I/Atlas was a wet, icy object venting enormous amounts of water vapor. If it were some kind of metal alien ship, that signal just wouldn't be there. So the verdict was in. It's a comet. A natural, very, very strange comet.
Okay, so the alien spaceship idea was officially off the table. But here's where the story gets even cooler.
Because solving that mystery only opened up a much deeper, more profound one. If it's a natural comet, why in the world was it so weird? Turns out, the truth is even more fascinating than aliens.
The new leading theory suggests that we've been looking at these interstellar objects all wrong. We thought they were these perfect, untouched time capsules from their home systems, but they're not. They are survivors. And 3I Atlas wasn't pristine. It had been cooked.
So, how do you cook a comet? Well, first, you let it drift through the galaxy for, a few billion years. During that epic journey, it's getting constantly blasted by high-energy cosmic rays. This relentless radiation bath literally cooks the surface, breaking down the simple ices and forming a thick 20-meter-deep crust of chemically processed slag.
And what was in that crust? When they analyzed the light coming off of it, they found something no one expected: tiny grains of iron and nickel metal. This is something we've just never seen in a comet from our own solar system. This wasn't just a crust of dirty ice, it was a metallic, chemically altered shell.
And that discovery led to this incredible new theory, a cryovolcanism engine. Here's how it works. As the comet got closer to the sun, its insides started to heat up, melting some of the ice beneath that crust. When that liquid water touched the metal grains, it kicked off a chemical reaction that released even more heat. You see, it's a runaway feedback loop. The pressure builds and builds until boom, the crust ruptures and you get these violent jets of gas and dust. That engine explains everything. The brightness surge, the weird jets, all of it.
So after all that, what did we actually learn from this one bizarre visitor? Well, its legacy has completely changed how we think about the galaxy and the strange travelers wandering through it.
I mean, this thing survived a brutal fiery plunge around our sun, which proves it must be incredibly dense and well-built. It's on its way out of our system now, but not before it gets one last gravitational goodbye kick from Jupiter in 2026. And as it leaves, it just shatters all our old ideas about what an interstellar object is supposed to be.
And this, right here, is the biggest takeaway. The space between the stars isn't some empty, gentle void. It's a cosmic radiation oven. The objects that travel through it aren't clean little relics. They're scarred, they're cooked, they're transformed survivors of an unimaginably long and violent journey.
You know, it may not have been an alien spaceship, but as one scientist put it, a rock that has traveled for billions of years, carrying the very scars of its journey across the galaxy right to our doorstep. Well, that is, in its own way, every bit as miraculous.
And that just leaves us with this one last incredible thought. 3I/ATL showed us that these objects are storytellers, their surfaces etched with the history of the galaxy. So it makes you wonder, doesn't it? What other cosmic secrets are scarred into the next travelers, just waiting for us to find them out there, between the stars?